And then once that is okay, we're streaming to YouTube now. Okay, great. Now I am going to start. It's top of the hour. So I'm going to go ahead. So here's just before we do this, I'm going to start the webinar. I'm going to lay the ground rules. Hey, we're recording. We'll send it to you afterwards. Invite people to do Q&A, and then I'll briefly introduce you, names and titles, and then I'll disappear and hand it over to you. And Jorge, I'll make you the host.
Sounds great.
All right, ready?
Ready.
All right, welcome everybody. I think people are kind of joining in as we go here. My name is Cameron Archer. I'm the content lead here at Tinybird, and I'm just kind of running background here on this webinar so that Jorge and Robert can focus on doing their thing. But before we get started, I can see that people are joining. I just want you all to know we are recording this webinar, so we'll send out that recording after we're done. So if you do have to drop, or if you couldn't be here, you'll get that recording. And then the other thing that I like to share, as far as questions, feel free to ask questions throughout the webinar, or wait until the end. If the questions are germane to what we're discussing, then Jorge and Robert will answer them as they're talking. And with that, I will hand it over to Jorge and Robert. So we've got Robert Hodges, who is the CEO of Altinity, and then Jorge Sancha, who is the CEO and co-founder of Tinybird. And so I'm going to disappear and I'm going to hand it over to them. Jorge, I'm going to make you the host, so you're in charge now.
Great. Thank you. Thanks, Cameron. All right. So welcome, everybody. I'm Jorge, and I will be sharing my screen here in a second. So we have just some backup slides for Robert and I to use as a background. How are you, Robert, by the way?
I'm doing great, Jorge, and thank you so much for having me as a guest.
Of course. I think this is, we've been talking about how this is not very common, two companies that are doing very similar things and competitive and to a certain degree, talking together and sort of trying to also teach about some of the things that we find in the field and about real time, which is what we're going to talk about today. So thank you for joining. Can you see my screen all right?
Yes, I can. If you want to, if you hit the slideshow, then I think you'll be set to go. Looks beautiful.
Okay, great. So yeah, let's get started. So we thought we would start. The plan is to do this more as a conversation than anything, so not like a sort of a strict presentation. So we thought we would start talking about what is real time and how we both came to real time, or our companies came to real time. So yeah, let's get started. Do you want to start?
Sure, I'll jump in. Yeah, so the way that I got in, well, first of all, a little bit about my background. I've been working with databases for 40 years, and I started with pre-relational databases. I've got a stack of books behind me, which are collected over a few decades. But the way that I got into analytic databases was that I joined Altinity. And one of my best friends, Alexander Zaitsev, is a CTO, and he told me a few, like back in, say, 2015, 2016, he said, hey, there's this pretty cool database. I think you ought to have a look at it. It's called ClickHouse. And the way that this really got kicked off was that Alexander was running analytics for an ad platform in San Carlos, California. So it's in the Bay Area. And they were doing managing what's called real-time ad bidding. And this is perhaps not super well known how data intensive this is, but I'm sure you can guess if you've ever put up ads. But basically, they built a platform which was generating up to 300 billion events a day coming off their ad platform. And one of the questions that they wanted to answer from this flood of data is a really basic question: is how much is an ad impression worth? So if you're running a platform, and I think all of us, and you and I both run ads, probably a lot of the people on this call run ads and know what it's like. You're always trying to figure out, hey, am I getting my money's worth? If I show this ad, is it, what's the value of this? Well, this turns out to be a surprisingly difficult question to answer, because you have literally hundreds of properties of one of these impressions, and the bids for the impressions. Like, where's the person from? What platform they're on? What's the creative they're showing? Sort of what's the, where is this going to be shown? And so you need to do some serious number crunching to figure out what's the value of this ad, so that what's the value of this impression, so that you can show it. And ClickHouse does this. And one thing I should add that makes this problem even more complicated is when you're valuing the impression, it's not enough to know in the market what the winning bid was. You have to see all the losing bids as well. And this is one of the things that explodes the data that you have to deal with, because it's just like, when you're buying a house or something like that, or maybe you're bargaining for a car and you say, oh, I'll pay you $30,000 for it. And the sale guy says, done. And you think, crap, well, I obviously paid too much. Otherwise, he would have had to go back and talk to his manager. So this was the problem that they were solving. And they were originally working with Vertica, which was helping them solve this problem when their data was at a much lower level, but they ran into scaling problems with Vertica that were basically related to cost. It was partially licenses, but it was mostly the fact that Vertica didn't use the hardware super efficiently. And so they needed a new solution. And to make a long story short, Alexander brought in ClickHouse. It had recently been open sourced in 2016, and he brought it in. They applied it to this problem. As I said, they sort of this torrent of data where they're loading something like 300 billion events a day, 3 million a second. And they were successfully able to solve this problem. That's what got us started. And the realization then was, hey, this database is really something special. The fact that it can solve this problem, enable analysts to deal with this torrent of data, get useful information out of it, there ought to be a company that supports it. And that's how Altinity got started and how we got into this business.
Super interesting. And it's incredible how sometimes the quantities of data that different businesses use. One day at Tinybird we keep finding like new magnitudes of data. Sometimes you find a customer that it's working with. You already thought you were working with amazing amounts of data, and then you find another one that it's doing things. So the amount of data that's being generated and the use cases being built on top of that, it's pretty amazing. And ads is one of those cases where it's almost unfathomable how much data gets produced and processed.
Exactly. And what's interesting is that the data is often produced by small companies. There might be problems that the companies that maybe have 6 people working for them, and yet they're dealing with billions of events a day. So this is
that's amazing. So I'll tell you a little bit about Tinybird as well. So we came to Tinybird through at Carto. All the founders of Tinybird, we met at Carto. We used to work there, and Carto was doing location intelligence. It was a technology based on Postgres at the time, and we could see how our customers were bringing huge amounts of data, almost like an order of magnitude more data on average every year. So maybe we would start with a customer that would come with a data set of 10 million records, which 10 million records for a database like Postgres, it's not nothing. You already have to start thinking about how to organize the data and so on. But the next year, that data set would have turned into 100 million, and the following year would have turned into 1 billion. And so Postgres wasn't really designed to scale like that, and in a sort of a you can obviously make it scale for those quantities of data, but on a sort of a case by case basis, and really fine tuning every single use case and so on, and throwing a lot of intelligence and know-how behind it. And what we were finding is that we spent a lot of time helping our customers pre-aggregate data, really think closely about exactly what data they needed to upload into Carto such that they could solve the use case they were thinking about. Instead of saying, hey, here's data, let me start querying and let me start building over it. And sort of, as it's being generated, we have to help them build these sort of complex ETLs and sort of massaging the data and getting into Carto such that they, it could then scale. And we were all developers, engineers, product people. We hated that. We were used to working with data directly, and we didn't need data engineers with us, to do the work. That data engineers is sort of a new role. We had database administrators, but data engineers almost become a new thing based on the amount of data that's being generated. And really, we started thinking, how could we work with 1,000 times the data? How could we make sure that the platform's going to scale and that people can throw data at it and start working with it? Eventually, Carto went into a different direction, which is leverage other technologies to add their magic, basically the geospatial location intelligence, and then. But we started going to other companies and saying the same things, which is whenever there is large amounts of data and you want to do something with it while the data is still fresh, especially if you want to enrich it with other sources of data, I always use this expression, is people throw cathedrals of infrastructure at this problem. They have something to capture the data, and then they move that data into like a data lake, and then there is some airflow pipeline that is getting that data and then putting it into a data warehouse, and then there is DBT or something like that, preparing that data, and then finally, if you want to do something that is low latency, you have to move it to a DynamoDB type of MongoDB type of database and still build an application. It just feels like a lot of things to do for something that is essentially or conceptually pretty simple, which is you have data, you want to write queries and do something with the result of those queries. So that's how we started thinking about Tinybird, which is, we can do better. We can make this easier, and it should be easier, because otherwise, at the rate that data grows, how are companies going to be efficient at building new things over this data? And we could sort of see there were two things that were never going to change. One is data was not going to stop growing, and people were not going to want to have results later. If anything, people want to move faster. It's a constant. So that's how we came to Tinybird and the problem we try to solve, and in doing that, we've discovered sort of real time as a concept and what it brings to companies and so on, which is part of what we want to talk about today.
Yeah, and it's interesting that you mentioned the word cathedrals, and I think of IT as going through waves of what I call cathedral building, where just like you had Romanesque, Gothic, late Gothic, these different waves of architecture in the Middle Ages. You get the same thing in IT, and the current era that we're in for cathedral building is, there's some AI stuff that people may have heard about, but it's building these real-time analytic systems. And I think, as you say, that in the same way that the Carto experience brought you to this new set of problems, for us, it opened up this whole world of applications and problems that could now be solved with real-time data.
Exactly. Should we talk about some of those?
Yeah, let's talk about them. Can I take one first?
Yeah, go ahead.
Yeah, because I think one of the joys of this is seeing the creative ways that people use use real-time data to drive their business, create new opportunities, and in some cases, create entirely new businesses. There were a couple of big ahas for me, but I think the first one was when I ran into an application which was designed to basically manage when you pop the question to say, hey, you've been browsing this site for a while. Would you like to sign up for a subscription? And maybe turn your ad blocker off too, by the way. And the way that they managed it was that as people were traversing the site, they were, their their browser was sending requests in, they were capturing the logs coming from the web server, and so they were tracking which pages people had visited. And basically, each time the page rendered, they would go back to ClickHouse, to the analytic database, run a query to say, okay, how many pages has this person visited? Assess their intent, and within about 10 milliseconds, return an answer back. Is it time to pop the question? And this is something that's just completely, with traditional BI technology, which tends to be kind of slow, kind of unpredictable in its performance. This would be inconceivable. And yet, with a database like ClickHouse, because you can reliably get, if you know what the question is in advance, you can reliably get answers in 10 milliseconds or less. You can now solve this problem. And it was just sort of like, aha! How did they think of doing this? Well, they did. It works, and it was kind of mind blowing, because then it opened up even more use cases beyond that. But that was my first aha in this particular area.
One amazing insight I've gotten over the last couple of years when it comes to real time, and precisely that use case, is how analytics has been used traditionally to understand the past. So to understand what's been going on in my website, what have been people doing, what are they interested in? Whereas with those kinds of use cases and using real-time technology like ClickHouse and companies like Altinity or Tinybird, you can affect the present. You can affect the user experience. You don't have to wait to see, okay, what have I learned about all of these users doing things? Let me make a change to my website and then wait again and see whether that's improving or not. You can actually, affect the user experience in real time, based on what the user is doing right now. What are other users like him doing right now? And what is the expected outcome here, or what is their intent, such that I can give them a discount, or and that's been a great insight to me in terms of what real time can do. And it's such a mind shift for companies, and some companies they say, no, we don't need real time for this. Well, if you haven't thought like this, if you haven't realized that actually you can improve and gather information and react to those insights in real time, you don't know what you're missing there in terms of potential upside. So it's really interesting.
Did you have particular use cases, that you handle and that you've seen your users doing that really, illustrated that point?
Yeah, we have a few personalization use cases like this one I'm describing, like detecting, so that we're capturing events for the users as they're browsing, for instance, in travel tech, as they're browsing like a hotel booking website, for instance, and our customer keeps like a vector, they've built like an inference, online sort of inference store with us, such that they keep a vector for each individual visitor. They don't know who this visitor is. It's a footprint, but they know how many times, what are the top destinations, how many times they've visited it, how many queries they've made, and based on that vector is being kept up to date in real time. And every time they take a step on the website, they're looking at this vector and sending it to a little machine learning model to get a response back to say, hey, what is the chance that if I offer them a discount, they're going to convert? So so that's an amazing use case that you think about how to do it without technology like ClickHouse, or it's hard, or use cases like we've seen this in booking.com. If you've gone in booking.com and booked, you get these type of things like 3 other people are looking at this room, creating, there's a bit of a dark pattern,
right, which both our businesses help enable, by the way.
creating scarcity, you know. But
Yeah.
actually, that's not easy. Like that require if you look at doing it without something like a columnar database like ClickHouse or technology like ours, it's not easy. Like you have to do something specific for that, technology specific for that, pipeline specific for that. They're capturing that data, storing it in a certain way, blah blah blah. Whereas actually, you know, you can now do it in a much straightforward way.
Right. And, you know, I think there's another class of use cases that I think ties in. You mentioned history and being able to look back, and you also mentioned being able to work in real time. I think that one of the use cases that we've seen is security and event management, which we have a number of customers that are doing this. And one of the key things about security events is you'd like to see them pretty quickly. You know, if somebody's breaking into your systems, you need to know, ideally within immediately, as close to immediately as possible. But at the same time, once you've gotten that real-time sort of response or the real-time notification, you now need to go back and look at the history of what was going on and what's behind this event. Hey, somebody's making all of a sudden making DNS calls to a site that is a known malware source. Okay, where did this happen? What's the prevalence? Is it associated with can we drill down to the application that is making this call? These are things that require you to go back into the history. And then, you know, like, hey, did something change in our application? You know, you're looking at differences and kind of doing slicing and dicing queries. And I think one of the real interesting things about this real-time data technology is it used to be that there were what was called a Lambda architecture, which would have kind of a fast feed, you know, where you would sort of be reading data straight off the event stream. This is Nathan Mars, like done back in the in the Hadoop era, and then you'd have a batch layer which would just be doing all the complex number crunching, and that data might show up, you know, like 24 hours later, and because they didn't have a database that could do both of them. Well, I think what we see in the real-time data use case is people are doing both of those in the same database. And that's been like a key driver to reduce cost and also just to reduce complexity. You know, these vast pipelines that do this batch data crunching, they just go away. And you just, everybody wants off-source data.
Yeah, and this is when we say that real-time creates opportunities, it has to do a lot with that, which is not just that you can reduce complexity, you can react faster, but is if you know the ability to we always say speed wins, you know, which is, and that applies to anything, and it has a compounded effect in the sense that if you're able to make decisions faster, you don't have to wait for these things to crunch, you know, but you actually can know immediately. The compounded effect of all of those decisions over time, it's huge, you know, and and it both from reacting to an opportunity that you may see, for instance, when you're doing a huge marketing campaign during Black Friday, or reacting to problems when suddenly you're seeing, hey, why are sales not coming in? Maybe there's an upstream problem here that we've missed, you know. So and then, you know, with there are other things like, for instance, smart inventory is an interesting one for big retailers who have warehouses all over the world, and they are constantly, those warehouses are emitting events in terms of, you know, for this item, one less in this location, you know, and so on. And actually, if you capture all of those events, getting a snapshot of how does this look exactly across the world. If I want to know how many shoes or how many whatever I have in a particular region at a given time, or if I have to make purchasing decisions, that's not an easy problem to solve, in the sense that you have so much events moving in real time that it's difficult to get a snapshot. But not only that, that has an impact also on sales, because when a user is buying, if you can't know in real time, I don't know if you've had this experience, but maybe buying Nike shoes or something like that, is you buy something and then you get an email saying, I'm sorry, it's out of stock. It's like,
oh yeah,
why did you sell it to me in the first place?
Right.
They sold it to me in the first place because they didn't know it was out of stock. They make an educated guess based on a batch calculation that happens every, So we've solved this for a couple of customers, and it has a huge impact that compounds as well in terms of user experience. So not just money in the moment, but money over time, as in better user experience, more people coming back. So all of those things are things that are not immediately obvious when people think about real time, but that's really important to us. Those kinds of things.
Yeah, and it comes down, as you say, to this compounding effect of making better decisions faster. That now enables people to just like order the shoes, know that they're gonna be there. For me as a vendor, to give somebody an offer and know that there's a reasonable chance that this is the better offer, that of the choices I have, this is the best one I can show them. It's exactly. There's a whole world of these use cases, and we see them every day.
Exactly, and then there's another aspect to it, which is doesn't have to do with the outcomes of the business, but it has to do with also, it has to do eventually with the outcome of the business, but it has to be, about developer experience, in the sense that, like, if you're working with a technology like Spark, which is great for certain things, but if you run a query and it takes 30 minutes, every time, you have to wait for 30 minutes to see the results, like the experience of building something is horrible, because and actually just having a great, like, being able to run queries that return immediately while you're developing, that also has a huge compounded effect in terms of building faster, happier developers as well, shipping more code, and so on. So that's another aspect also that we
and that's a really important point, because from an analyst perspective, actually at LifeStreet, the company where Alexander originally used ClickHouse, the analysts had a word for that kind of 30-minute query, and that was the not worth trying disease, which means that you just knew that if you queued this thing up, you're going to wait so long that if you got it wrong, you didn't have to repeat it, and you get basically 16 queries in an 8-hour day at that rate. So not worth trying disease was something they were combating with with this new real-time data technology.
Slightly unrelated, but when I started developing, one of the first integrated IDEs that I used was WebSphere, IBM WebSphere, like a long time ago.
Yeah,
I'm an old. I just aged myself right here. But it was so slow just to open. It was so slow that we had what we said in the team is that IBM WebSphere makes you sleepy, because by the time it had opened, you were yawning already. You were just bored waiting because you couldn't do anything, So this is a similar effect. If you can't immediately get feedback, quick iteration, it's like, how productive can you really be, So I think that as data grows and as developers need to validate things with data at larger scale and so on, having something that it actually, you feel like, wow, this is great, and it returns super fast, that is really important as well.
Yeah, because I think of real time as actually having a couple of components: real time reaction to the outside world, but then real time when people ask questions. And and I've been there on WebSphere. We used to call it the pig. So it was it was a beast.
Should we move on to
absolutely.
If you want to take a crack at this,
sure. I think that because this goes back to WebSphere, where I think really illustrates the problem that the problems that we're describing were actually solvable in earlier times with appropriate technology, but it was extremely expensive. So, for example, I worked at Sybase in the 90s, and we did a lot of we dominated Lower Manhattan and Wall Street. Because people were building trading systems, and they needed to be really fast. And if anybody who's worked in the financial industry knows that they will pay any amount of money to get the winning, to win at trading. But what has happened is that this technology, which is basically proprietary and available only to a few people, has really just opened up in the over the last decade or so in particular. And I think probably the single biggest thing, I'll just start with one. I think open source has had a really fundamental effect here. That the technology, the data warehouse technology in particular, analytic technology, beginning with Hadoop, which was sort of a first crack at this problem, was open source. So all of a sudden, any developer, given it with Hadoop, given a machine large enough, anybody can run it. And that began sort of a cascade of projects that were focused on analytics and were accessible to all developers. Not only that, they were often, not always, but generally driven by people who were solving a problem that they had. So they weren't, Hadoop is a classic example. It was solving an analytic problem at Yahoo. And that's how Doug Cutting got, they had to solve this problem. They needed to crunch data. They were trying to figure out, okay, how can we do this at scale? Came up with, the notion of using MapReduce and built an implementation for it. So this open source has had a huge influence, and as a result, and I think over the last decade or so, we've seen several really outstanding efforts to that have fundamentally changed the analytics and have led to people being able to solve the problems in the way we were just discussing.
Yeah, absolutely. I think. I don't have much to add to that. I think that is absolutely key and has been absolutely key to the development of many technologies. And you can sort of see what's happening in AI right now, which is some of the open source models, they're almost as good already as the closed ones,
Yes.
So
yeah,
which makes complete sense, and that's it's a testament to the strength of open source, and the potential of open source.
absolutely. And I think it's also led to an evolution of software and kind of a crowdsourcing effect that I think the best example is you and I, as you said at the beginning, you and I run businesses which, in another universe, we would be arch enemies. And yet there's this underlying software that we both share that we have a combined interest in making it better, fixing it. And in fact, we talk about that regularly. By the way, thank you for your bug fix to for the string aggregate problem last fall. That was a really great one. Helped a lot of people.
I'm going to take all the credit, and I've done nothing specifically myself to solve it now. I'm just kidding. Yeah, thank you for saying that. I'll pass it along to the team.
Yeah. So
and look, that's super important. Also, the fact that we can talk about and agree on where should this technology go, and discuss over that and so on. That's really cool. And giving back to the community is also great. Like we use your company and mine are built on top of open source technology, not just ClickHouse, but everything else, and so for us it's really great that we get to contribute back by just fixing problems or moving things forward and so on. So that's good.
So what out of that list down there, are there others that are really important to you that you would dive into and just explain how they've changed the market?
I think event streams is a really important one. And event-driven architectures, I think, have set the stage for real time. Because the first problem you have is how do you capture the data, and how do you capture it in a safe way and in a way that you can read at different speeds and different moments for different purposes. I think Kafka, for instance, has been a huge multiplier for real time. It's my take on it, because back in the days of big data, everyone was talking about big data and how big data was going to change everything, and I think companies were feeling incredibly anxious about, I have all of this data, I don't even know where it is or how to capture it and so on. So Kafka sort of gave the market a way to, okay, with this you can capture the data even if you don't do anything with it. You now know that you can, and you have a way to do it, and you have a way to exploit it in many different ways. I think that's been a huge facilitator for real time, because before that, everyone was doing their own thing to capture the data, and it's not that everybody uses Kafka right now, but Kafka and other projects like Kafka have made that like a really sort of convenient, almost standard way to capture huge amounts of data that you can then consume as soon as you're capturing it.
And yeah, and the interesting thing about Kafka was that it developed completely independently of data stores. It was, and I think that because message buses already existed, people have been using them in enterprises for decades. But Kafka
like
was
different.
Queue
or
exactly like RabbitMQ, but they were much more closed models, and they were sort of like there was an assumption in many of them that the producers and the consumers knew who they were because they would share data types. With Kafka, not so. I mean, Kafka, you just throw it in the producers just throw it in this big pipe, and the consumers read it out, and there can be as many of them. They can replay it. And Kafka is that central log that just holds this stream, often months of data. There's some very, very large Kafka installations. So yeah, that one's been a huge step forward.
Absolutely.
I think. Please go ahead.
Yeah, I was going to say probably Kubernetes has been an important one for you guys.
Absolutely. Yeah, Kubernetes is a new private cloud. I used to work at VMware before I started in this job, and VMware gave people this ability to, the fundamental thing it did was it allowed them to utilize their hardware efficiently at a time when, when it was hard to pack a bunch of applications onto hardware and use all the cores. And so it solved that problem, but it also gave people a stable platform that ran everywhere. And Kubernetes does the same thing. So you basically can take an application on Kubernetes that runs on one of the machines on my desktop, and if it runs there, it will also run in Kubernetes running Amazon, it'll run in GCP. So it has this tremendous impact on portability, and it means that we can build services that will run essentially the same way in multiple locations, and they also use the hardware and the underlying hardware very efficiently. This has been key to being able to control costs, and also in two ways. One is utilization, which is always a concern when you're running applications, but the second is a lot of times costs are affected by where you run. So having the ability to choose, like, hey, I could run in the cloud, but actually I need to run this one in my data center because I'm going to really play around with the hardware and make this thing really scream. Being able to have that choice is something that Kubernetes enables.
Yeah, absolutely. And for us, we've sort of jumped over a few ones. I'm conscious of time here, but serverless for us has been an interesting one. Because I think there's always going to be businesses that want to have full control over absolutely every knob and every configuration to extract the maximum value of, or have maximum control over what they're building. But we've also seen a huge interest with this, we've seen things accelerating in terms of from the moment, if you think about cloud, for instance, it was a huge change in terms of how quickly you could build a business, like a SaaS business, for instance, as compared to before, where you needed to provision servers or buy servers from someone, So in a similar way, like serverless is almost like one layer on top, which is, I don't even want to know what's underneath. I want to be able to build quickly and to get to a solution that I can trust, that it scales, and that I don't necessarily need to understand everything that's going underneath. And we see a lot of that. Initially we were seeing it a lot with small startups that just want to go fast, but we're seeing it more and more with bigger companies, which sort of are and some of them are coming to the realization of, hey, if I don't have to invest in infrastructure developers, let's say, in DevOps people, can I get that money and invest it in developers so that we can ship more without having to, always be thinking about how do we manage this, how do we scale it, and so on. And we've seen that play out in a few companies, and it's been pretty exciting. So that's another area for us that we think is, it's facilitated real time as well. In our case, in the sense that we try to make it very easy for anyone to do without having to really necessarily, back to my original story about how we came into sort of Tinybird and so on, of, hey, I have data, I know SQL, I just want this to be super fast, and I want it to be querying over what's happening right now. So that's another area for us that of a lot of importance.
Yeah, I think that there's some of these others we can skip over, but I would highlight as the last one before we go to our favorite low latency column store is visualization. And when I started this job over 4 years ago, I sort of expected, okay, we're dealing with data warehouses. AI is getting really big. We're going to hear a lot about AI and integration with machine learning. And it was crickets. I think maybe 1% of our customers have ever asked about this. They do run ML. But they're separate systems. But what every single user of ClickHouse and of our systems cares about is visualization. And that is, along with event streams, I think that's the other key element of these successful systems, is to be able to create UIs that allow people to do slicing and dicing queries, to count things in different ways, to display data in different ways, and then just use the amazing ability of humans to recognize patterns in the data. This is, I think people underestimate. Humans are not humble by nature, but I think one of the places where we do sort of sell ourselves short is just how good we are at recognizing patterns and being able to dive into it. And so, there's sort of tools like Grafana, like Superset, a host of other BI tools, and then on top of that, you have these really great JavaScript based toolkits that allow people to build custom graphics that are just amazingly responsive. And I think that's a really fundamental part of some of the more successful systems that we've seen.
Agreed. Absolutely agreed. And I think, low latency column stores. I mean, I think one of the interesting things we've seen here is, there was this big NoSQL movement, because it made querying over large amounts of documents really, really fast. But and that's where SQL was pronounced dead, I think, a few times. And then interestingly, like column stores and the ability to query structured data and do joins over huge amounts of data, and then have aggregation capabilities and all that has been it's the way to go for analytics right now. Then there's also the sort of the separation of storage and compute we could talk about, which I think it's still not 100% there, and I think it still is something that it still needs some work, but
there's still some assembly required.
Yes.
Yeah. Great. Should we dig into ClickHouse a bit and why we think it's unique? You want to take? Why don't you take the first crack at what you think makes ClickHouse great?
Yeah, I mean, when we started tinkering with ClickHouse, we were super excited because we thought these guys are crazy. Like, you have to be crazy to build this database, because it was like ambitious. It was designed to be super, super efficient at every single thing. Every function was designed to be incredibly efficient at what it did. And so we fell in love with it really quickly, even when all the documentation was in Russian. and it really, we love the ability that it has to scale both horizontally or or vertically, and being able to either run queries over huge amounts of data or run thousands of queries over also huge amounts of data. So those things, the combination of being able to simply write SQL and get those results, we find amazing. And really, Tinybird started with we weren't even thinking about real time at the beginning. We were thinking about, this is a Formula One. How can we enable a driver, not a Formula One driver, but any driver,
right,
to drive it, without needing the mechanics in place the day of the race, and having trained for 20 years. It's like, how can we enable any SQL developer to take advantage of this amazing database, and because we love it, and we wanted to help any developer make the most of it.
Yeah, that's a really important point. That drag racer image, I think, is one that most of us who use ClickHouse have in mind, that it goes straight, doesn't do curves so well, and you really need to handle it. Needs to be handled with care to be used effectively. I know for me, I think that, when I look at how our users use ClickHouse, I mean, it has the properties that I have a slide that I do when I do ClickHouse performance talks, and I talk about all the performance optimizations. And the short story is, if you can think of a way to make a database go fast, there's a pretty good chance ClickHouse uses it somewhere. So,
yeah.
But I think that for users, what they get out of it is this ability to do aggregates directly off source data. So you're reading in trillions of rows. You're going to run your queries straight off the sources, as opposed to having to prepare them, and in order to have your application work. And when I first started, I didn't understand what that meant. What do you mean aggregates? Well, it's counts, it's sums, it's histograms. The point is that these are the operations that you use so that humans can get insight into these huge volumes of data. We never look at it. We rarely look at individual rows. I mean, sometimes if we're doing log management, we do, but generally speaking, we're getting, we're doing averages, we're doing, number of unique visitors per hour, something like that, things that allow us to reason about these enormous data sets. And ClickHouse does this exceedingly well. And in fact, it was the original problem definition when ClickHouse was developed. It was developed to solve web analytics, to do essentially the same thing that Google Analytics, to drive that kind of application, like Google Analytics. And it was just, hey, take the source data, any aggregate that the user wants, compute it on the fly, and hand them back a result. And it is amazingly good at that.
Yeah, absolutely right. Absolutely right. Hey, we have like 10 minutes left.
You want to show how you guys help users? That's, I mean, you've got these challenges, but maybe we could, if you want to show, I mean, I think there's a set of challenges that everybody faces, ranging from finding expertise to being able to build apps and not infrastructure. I think these are things that I mean, they're true of databases in general, but particularly of analytics. Do you want to show jump to showing how Tinybird attacks this problem?
Let's do it. Let's make a quick demo. So let me see here. Sorry, I'm just jumping over every single one. So I'm going to stop sharing and reshare just the screen so I can have it in front of me and not in the other window, because otherwise you'll see me with my head turned all the time. So I'm just going to share this screen. So might be a bit big, but I'll make the screen bigger here. I'm going to get this out of the way. Can you see my browser?
Yeah, it looks great. It looks great now. Thanks.
Okay. So so Tinybird essentially, as I was saying earlier, it helps any developer, any SQL developer, and could be a data engineer, backend engineer, anyone that is data savvy to take advantage of ClickHouse and build APIs over a large amount of data without having to do any infrastructure management at all. It's a serverless product, and essentially when you log in, you create a workspace. So it would look similar to basically just ask you, hey, how do you want to name this? And then you immediately create the workspace. So there's no, you don't have to specify what size machine you need or anything like that. You don't have to worry about any of that. So I've created this one. It's called Live Session. This doesn't have anything here yet. There's two main concepts in Tinybird, which are data sources and pipes. Data sources is the source of the data, which can be a very different set of data sources. It could be, you could just send data to us through our Events API, which is a HTTP streaming endpoint that you can just throw data at us simply as ND-JSON, and we will ingest it. You can send us files. You can connect to Kafka, to Confluent, BigQuery, Snowflake. We have more and more connectors coming up, such that in the same vein of not having to set up any infrastructure, all of this is managed. And so, for instance, if you had that data in Snowflake, you would just enter your account and password. It enables you to choose data, and then you can select what tables you want to bring along and how often, and that's what happens. So for this demo, I'm going to use one really cool thing we've created recently with using AI, which is a way to create a schema and start generating data as a sample data. So for instance, I could say here, generate a schema for for analytics events that track users across a website, for instance. And if I do this, it's going to generate a schema that makes sense for this use case. It's going to show it to me in a second. And so you can see user ID, page URL, browser type, page title. So it's added a bunch of columns, event type, refer URL that you would expect to see if you were building a schema. Normally, this is just for demo purposes, and we've done it so that it's easy for people to test, but it's perfect for this demo. So if I say confirm and ingest here, it's going to start generating data and sending it to this data source. And you'll see in a second how that looks. Essentially, in the background now, it's created the data source, which is it translates to a ClickHouse table, and it's ingesting data. You'll see it in a second here. This chart is going to show me how data is starting to come in, and you see that it's making up the data. Obviously, event type wouldn't be this horrible set of characters, but it's enough for me to show how Tinybird works, basically. So from here, I can rename this as website events, and if now I can start building over this. And in this example, it's going to be ingesting for 10 minutes because it's for demo purposes. But you could imagine the same thing coming from a Kafka data source, like a Kafka topic, and it works exactly the same. You select a topic, it shows you what you're going to see, you create the schema, and it starts ingesting data. All of this stuff you can do not just in the UI, you can do in the CLI. I'll show you very quickly how that looks at the end. But the moment you have data, then you can start querying. So we do this in Tinybird with something called pipes. And in this case, we're going to do like a simple stats pipe. You can add markdown description as you go if you want to document it for other people to see it. And here, for instance, I'm going to name this node filter data, and we're going to do some the outcome of this pipe is going to be an API. So what I'm going to do here is I'm going to select what columns I'm interested in, I can start shaping the results. So let's say I'm interested in the event timestamp, and I'm interested in the page URL and the referrer. As you can see, we have a code complete as well. Sorry, how do you call it?
Automatic code. Code completion.
Code completion. Code completion. Yeah. Exactly. And then device type and browser type. So I'm just going to select these columns because these ones are the one I'm interested in for this use case. And I'm going to filter it by, I'm just going to put an example here. Device type equals desktop, for instance. Let's say I'm only interested in desktop, so I can run this query. Sorry, is it not device type? Let me see.
It's a device type is you got a misspelling there. DEI.
Oh, I see.
Yeah,
good one. Okay, so
cool.
I have now this filter, and the way we've done this is that these pipes, you can instead of doing complex queries, what you can still do, but if you want to break up the queries in blocks, I can now basically do my aggregations here and query from the filter data. So I could do select from filter data. So I'm querying the result of this query. So here I'm going to do something simple. So I'm going to say, let's say that we would like to see like count of hits per browser as hits from filter data, group by browser type. And if I do this now, I can order by hits, for instance, to make it like a top descending. And as you can see, one of the things that we're talking about is how quickly you can develop when you can run queries, and they return super fast. So so this is how, like 0.51 milliseconds, is how much these queries are taking, which is pretty amazing. So let's say you wanted to use this in an application, in a dashboard, whatever you want to use it. You can come here and create an API endpoint, and by selecting what is the output node, and immediately you have this information in JSON or NDJSON or in CSV or Parquet. And essentially, this is one API you don't have to build. You already have, you don't have to go and, we become the analytical backend. And now you can just paste this somewhere else and integrate it in your product right away. And you can do a bunch of things. I don't want to keep going, but you can add parameters. So you have like a templating system where you can introduce parameters. So if I wanted to, instead of just filtering by this device type, I could pass this as a parameter. So I could say, so I'm interested in any one. I'm going to call it device, and by default, I can say it's desktop. But if I now have a dynamic parameter here, if I come back to the API, you can see it's sort of automatically documented. You can add a description. And then in the device here, I don't know, I didn't look at the other ones, but probably let's go with mobile. You see that, and now I have the results from mobile instead of for desktop. So that's the gist of it. And the last thing I'll say is that this is like the UI is great for developing and for understanding the data and for making progress, working as a team. But when you want to, as you and I will know, big analytics projects require data ops and code and so on. So you can take one of these tokens and then use it in the CLI. I'm going to make this bigger so that I'm just going to paste it here, and then now I'm connected from the Tinybird CLI. Just make it a little bit bigger because I have a big screen. And I can say TV pool, and this is going to write as serialized to text so serialized to text the data source that have been created. And if I open Sublime, for instance, you can see them here. This is the data source with the schema and how it's extracting the data, and the underlying ClickHouse parameters, and this is the pipe. So you can use this in your, with Git and do, you can, with the CLI, you can build tests and all these kinds of things which you need in order to build applications that we want to facilitate. I'm going to stop here. Maybe that I went for a bit longer than we planned.
Cool. I'll tell you what, then, if you switch me over to the host, I'll show everybody a contrasting view of how we attack this. Looks like I can share. Oh, you'll need to.
Can you share, or do I need to make you the host?
You'll need to make me the host.
Okay, go for it.
Ah, that feels good. All right, let's pull this up. So actually, let me move the stuff on so that you'll actually see something interesting. All right, so we took a kind of different approach, and I think what's really cool is.
Are you sharing? I'm not seeing it.
Yep, I'm just.
Oh, there you go.
So if you can see that, yeah. So we took a very different approach. You guys have built a PaaS, and you have some really impressive application development features. Our approach has always been the database as the core. So we grew up as DBAs, and so what we built was a platform which is designed to enable you to basically automate and control any aspect of running ClickHouse, and also to run it anywhere. And what I'd like to do is just show you examples of this. So, for example, if we go to let's go pick a. Here we go. Here's an example where we have what's called an environment. We're running a bunch of different clusters. This is one that contains about 1 trillion rows of data, and it's actually running in Amazon EKS, and it. You can do all kinds of, sort of all the usual things that you expect to be able to do. For example, you can upgrade the server, you can rescale it, so scale it out, scale it in. You can pause it. I'll show you an example of that in a minute. You can do backups. So all the operations that you would normally have to script and deal with, these are all dealt with in this API. Moreover, we have very detailed views of what's going on inside the cluster. So the metrics is all built in, all your favorite. We're actually one of the we are the maintainer of the community Grafana plugin for ClickHouse. So we have these metrics. Again, this is something that you don't have to worry about setting up yourself. And on top of this, and I think this is a really important part of the offering, because we are focused on the database, we have enterprise support just baked into this. So we have really great database people. And, as you're building your application, if you have a question like, hey, how do I integrate with Kafka? I'm running an MKS, the managed Kafka service on Amazon. How do I get that to talk to my ClickHouse database? We have people who know how to do that. And also, as to be able to help you to tune it, to do your schema design so that you will minimize the amount of data. That's all baked into this. And the speed on this is phenomenal. So this is, I'm talking to that database right here. Let's just confirm. Yeah, we see the version. Another thing we do is we have production ready ClickHouse builds. So these are called Altinity stable. They're available and supported for up to 3 years. We certify that they're ready for production use, and then we will backport fixes into them even well after the community has moved on. I'll just give you a quick example. Let me pull up a query here and just show you the speed. So for example, here's a query. We'll see how fast it runs. I've got some temperature sensor data here. I'm asking, hey, what was for a certain sensor on this trillion row data set? What was the day that it found the maximum temperature? So there it is. So we get that back in less than a second. This is an example of real-time response, or close to real-time. And in fact, we can make it a little bit better. It tends to bounce around because of cache effects. What we can also do is people can build using materialized views. They can build the true real-time data, which is to get that answer back in the time that a page takes to render. Let's show an example of that. And there it is. And we'll just run that one, and boom, we get it in 23 milliseconds. Typically, if you call it a couple times, you'll get enough cache heating effects that you'll be down to around 10 milliseconds or less. It's really, really fast. So this is a performance optimized, completely automated ClickHouse as a service. A lot of people are focused on that problem. One of the places where we deviate, besides having the baked-in support, is besides having these builds, which you can also run externally, is we can manage things anywhere. So this is an Intel NUC, and one of the things we can do is actually manage a cluster there. So let me show it to you. It is, let's go find it. Here it is, Robert's NUC. And there it is. So that is showing you the current state of this cluster. One of the cool features we have in this is that we can automatically turn compute off when it's not being used, and then I can restart it at any time. So I'm going to just go ahead and resume this 2-node cluster. And to prove that this is not, somewhere in the cloud, let me just pull up this is a window where I'm SSH'd into that, into that Intel NUC that I showed you. And if we watch this for a minute or so or less, what will happen is you'll start to see this spawning up Kubernetes pods to enable this this cluster to come back up again. The point here is that we can basically run and manage ClickHouse practically anywhere. The only requirement is if Kubernetes can run there, we can manage it. And so our goal here is to enable people to have that choice. And here you can see things like Zookeeper now coming up, have that choice of running, where does it make the most sense for the business, and also to have complete control over the data. One other interesting property about this system is you can actually unplug us and have us go away, and you will continue to, your analytics will continue to work. So you're not tied. Yeah. This is sort of, we call this vendor unlock-in. So it's and I think it's kind of a cool illustration of, we have this shared core of open source, Jorge, but we've taken really different takes on the market. And I actually think one of the reasons we get on is this market is big enough that there's customers there for both of us. And I think we actually make the ecosystem richer by taking these different approaches and giving people choices.
Absolutely. So yeah, I think we're about time. I think we're just over a few minutes. I don't know if there's any questions. Cameron, I don't know if you're still there. I actually wasn't looking at the chat at all.
Yeah. Oops. There we go. I don't see any questions queued up right now. So looking at if people want to ask a question in the Q&A box, or if you can get to the chat, assuming that's enabled, we'd be happy to answer them.
Yeah, and here are our emails as well.
If
you want to get in touch with any of us.
Yeah. Once again, Jorge, thank you so much for having me as a guest. It's been a real pleasure to talk through these issues, and I think this is such an interesting topic, and I think the creativity, in addition to having fun working with you guys, have obviously had some real fun developing the Tinybird, but I think there's also this, beyond making money, there's just this joy at seeing the creative ways that people can use this technology. It's a real pleasure to work on it.
Absolutely. I have the same exact feeling. Oh, there seems to be a question.
It's Diego who's saying, telling us we did a great job.
Thank you, Diego. All right. So thank you very much, Robert, and absolute pleasure as always.
Yeah. Thank you very much.
I'm going to just jump in and say, sorry, Robert, for interrupting you. Just remind everybody who is watching that we will send out the recording to this very soon. So keep an eye out for that.
Thanks, Cameron.
I was just sitting here watching. Y'all did a great job.
Thank you. Have a great day, and talk to you soon.
Okay. Bye-bye.
All right. Bye.